In my previous video on Langgraph, we built a React agent and we implemented this graph where we have an AI assistant and we have a tool, this conditional flow between the agent and the tool. And eventually after using the tool, the agent is going to go to the end. In this video, let's dive into the specific case of a chatbot, and we will make it use a browser as a tool, and we will implement this graph. And in the upcoming videos, we'll continue to build on this chatbot. For instance, we'll be building the tool usage in this video, but in the upcoming videos, we will be working on memory or human in the loop or time travel, and also look into deployment. So let's get started with tool usage. So to get started, we need to make sure python.env is installed, and we are going to be loading the environment variables. And I'm particularly going to be using OpenAI API key, as I'm going to be working with OpenAI family of models. But you can choose to use Gemini or any other models. So I've created a .env file that is going to hold all the environment variables. And in my previous video, we saw about creating a simple React agent. And in this video, we're going to be looking into building a simple chatbot. And I've also got the requirements.txt file that has listed all the dependencies that are needed to run these notebooks. And I have committed all the code in this GitHub repository, which is public. And I'm going to be adding the link for this repository in the description of all of the videos. You can check out and make use of the code. So with that note on the setup, let's get started. So let's start by building a simple chatbot first. We will be importing the state graph, start and end nodes, of course, from langgraph.graph. These are kind of the essential nodes that are needed to build any graph. And we, of course, need the state, which is a type dict, and it has only the messages because we are building a chatbot. And the state is shared across all the nodes that are there in your graph. This is how I see the states, basically. So the state is something that is shared across all the nodes that are there in your graph. So in this case, let's say we have two nodes, node 1 and node 2. The state is passed into node 1. It can be modified or it may not be modified, depends on what the node 1 does. And node 1 again outputs your state that is modified or not modified. And again, node 2 takes the state and it can modify or not modify. Again, it needs to output the state. And that is how the state is shared between all the nodes, and they flow from one node to the other. And inside the state, we only have the messages because it's chat. So the messages is a list. And how we are modifying the messages is by adding messages or appending messages to the existing messages. So if you think of chatting, that makes a lot of sense. Whenever the user gives any input message, it is going to be appended to the existing messages. So that's what exactly is going on here. And then we need to create a chat node, which is going to obviously use a LLM. So the LLM of choice is OpenAI GPT-4.1. And we create an LLM. And in order to create a node out of the LLM, we need to create a function that takes the state as input, and it's going to invoke the LLM. And we can see that the state obviously has the messages inside it. We pass the messages to the LLM and invoke it. And whatever the response that we get, we are going to return as the messages. So that is how we create a chat node. And once we have the chat node, we can now go on to build the graph. Again, to build the graph, we will be doing a state graph. We'll be first creating an object of the state graph. And the first edge is from the start to the chatbot, as we can see here. And we are adding the chatbot with the name of the node as chatbot. And again, we are going to be having the flow from chatbot to the end. So once we have defined the graph, all that we have to do is graph.compile, and we have the graph that's built, and we can import image and display from IPython display, and we can visualize it as an image. So that is the simple chatbot. So now that we have defined the graph, we can chat with the bot. So we will have an infinite loop. And whenever the user input is, quit or exit or queue, then we're just going to break out of the loop. Otherwise, we are going to stream the graph updates with the user input. And what is that user input? So that's passed to the stream graph updates. which is going to stream messages into the chatbot graph. And the chatbot graph is what we created here. We're going to loop through the stream, and then we are going to print what the value of the assistant is, which is nothing but the output from the LLM. So that's a simple loop in order to work with the graph that we just created. If we execute that and ask the question, what do you know about Langgraph? Then we get this answer. So that was the chatbot without using any tool. But in real world, we will be having chatbot that actually uses tool. So let's look into how we can use tool. In this case, it's a browser. And for the browser, we are going to be using Tavily. And Tavily is a tool that is going to connect your LLM to the web. If you want to use some of the tool, you can browse through some of the search tools that are available there in the LangChain website. For example, there's Brave Search, there is, Bing Search, and there's quite a few. And we can see that Tavily Search is also there at the bottom. And so we are going to be using Tavily Search. There's no particular preference for me. It's just a random choice. So to get started, we need to do pip install LangChain Tavily. So once that is done, we will have to load environment by now setting the Tavily API key. So if we go back to our repository, we can see that we have a .n file. So in this file, we need to now also add the Tavily API key. And here you can log in. And once you log in with either Google or your GitHub account, you will be able to readily generate an API key and then use it in your notebook here. So once the setting up of Tavily with API key is sorted, all that we need to do is from LangChain Tavily import Tavily Search, and we need to create an object of Tavily Search as a tool. And one of the parameters we can define is the number of results that we want to actually fetch from the search. Let's say we define it as 2. In order to invoke the tool.invoke and then pass our query. In this case, what's a conditional edge in Langgraph? And we can see that we got 2 responses because we said the max results is 2. So the first one is that of this URL, which is a Stack Overflow URL. And then the second one is that of a Medium article. So those were the 2 responses that we get. If we set it to max result of 5, then we can see that it's going to take a while, but we can see that we're now getting 5 responses. So the browser tool is now sorted. One thing to note is that we need to make it a list. Even though we have only one tool that we're going to use, we have created a list out of it, and we are going to be passing this list to the LLM. So we're going to say LLM.bind tools, and we're going to have the list of tools here. So that's the LLM with the tools. So we need to bind these tools in order for the LLM to know the JSON format that it needs to use for the particular tool. Otherwise, the LLM wouldn't know the format in which it needs to interact with the tool. So with that sorted, with the LLM sorted, we can create a tool node. So whenever we have a tool, it's important that we wrap it in a tool node. Otherwise, we won't be able to make use of this tool. So that is what exactly we are going to do. In this case, we have defined a class, which is a basic tool node, and we are saying that it's a node that runs the tools requested in the last AI message. In order to initialize this class, we will be getting the tools by name. It's a dictionary that maps the name to the tool. In the call, we'll get the input message, and if the output for that input message is a tool call, then what happens is the tool call will be invoked and the result will be obtained. And the result will be added to the content, and it will be wrapped in a tool message. And eventually that message will be added to the output. So all that we are doing is we have the output, but if there's a tool call involved in the LLM invocation, then we are actually going to invoke the tool and then we are appending it to the output. It's important to note that we need to use an LLM that supports tool calling. For example, OpenAI, Claude, and Gemini, they all support tool calling. But if you're going to use an LLM that doesn't support it, then this is not going to work. So that's just something to keep in mind. But almost all of the LLMs, they support tool calling. So with that being done, we can now create our graph. So we have the basic tool node, which we just created. We pass the tool to it and we create the tool node object. And we will add a node called tools and we will pass the tool node. And if we visualize that, we can see that there's a tool node here But somehow this tools is not connected to the chatbot, but this is not what we want. Somehow we want this tool to be connected to the chatbot, and we want a React loop between the chatbot and the tools. So let's see how we can go about that. So obviously we have added the node, but we haven't added edge. For example, there's an edge existing between the start and the chatbot, that is here, but there's no edge between the chatbot and the tools. But this edge is going to be a conditional edge. So how do we incorporate conditional edge into this? So we need to define conditional edges. So this is going to be fairly simple if we use predefined functions from Langgraph, but we are not going to do that because we are doing this for the first time. But in the end, I'm going to show you how we can use the predefined functions. But for now, let's just stick with this. So the chatbot should be basically able to decide to either go to the end node or go and make use of the tools in the tool node. And from the tool node, it needs to return back. It basically needs to decide to route to in either one direction or the other direction. And so we need a routing tool to accomplish that. We need to define a routing tool. And all that happens here is that if there's an AI message, which is the response from the LLM, and if the AI message has tool calls, then we are going to return tools, meaning that we are going to take the direction of the tools. Otherwise, we are going to take the direction of the end, which is the other side. And that's how we will be routing between two edges. And that's what it says. We need to use in conditional edges to route to the tool node if the last message has tool calls. Otherwise, we'll route to the end. And we need to make use of that now. So we will be adding a conditional edge. And from the chatbot, we will be using the route tools, and we'll be routing either to the tools or to the end. And we have added that as one of the edges. And now if we visualize, we can see that from the start, we go to the chatbot and we can see the dotted conditional edges going between the end and the tools, and from the tools it's going back to the chatbot, and this leads to a React loop that the chatbot can use as many times as it wants. And so the chatbot is now an agent. What we did was write this function, which is kind of redundant because there is something pre-built inside the Langgraph to make our life easy. Similarly, we wrote this class, which is to wrap the tools into a tool node. So let's see how we can make use of the pre-built functions or classes in order to make our lives easier. So there's something called Langgraph.prebuilt that provides the tool node, and it also provides the tools condition. That is nothing but the routing condition. So all that we need to do is we need to create an instance of the tool node class and pass all our tools there, and we get the tool node. Similarly, for the routing, all that we need to do is just give the tools condition here and create a conditional edge. And with that, we can just create our graph by defining the different nodes, the chatbot node, the start node, and then the different edges, the tools edge, and then the conditional edge. So after doing all of that, if we display the graph, we can see the same graph is created, but this time using pre-built tool node and tools conditions. So now that we have built the graph, we can execute the loop and then see how the LLM chats with us. So this is the standard loop that I showed you before, but now we are using the graph that we created using the pre-built functions. If I invoke that, and if I ask the question, how can we create a tool calling node in Langgraph? It says, sure, in Langgraph, often used with LangChain Python. A tool call node is a node that, when reached during execution, triggers a tool, for example, a function, an API, or an external utility, and incorporates its result into the graph. And it's also giving us the example of how we can run the graph, how we can compile it, and how we can go about creating a graph. So that's pretty much what I wanted to explain in this video. So now that we have seen tool calling, in the next video, let's look into adding memory to the system and why we need memory and what memory brings to the table. So until then, I'm signing off, and I will see you in my next video. Take care.